Hello everyone, this is Amit Parse. I am a certified ethical hacker, forensic investigator, and cloud migration consultant. Welcome to my session AWS DevOps. Today we are going to discuss about Terraform. Basically, Terraform is a IAC provider, infrastructure as a code provider. Why we need Terraform? What all are the alternatives available for the Terraform? What advantages Terraform gives me? And in which scenario we are going to use Terraform? These points we are trying to cover in the today's session. Okay, so here is the basic diagram. Before we plan anything, before we discuss anything, it's always a good idea to document it in terms of a scenario. If the scenario is a visual scenario, we will be easily able to figure out the flow. So here is the flow that is in front of you. Scenario is, you are working as a DevOps engineer, and the basic requirement is whenever developer is going to commit the code base into the repository, maybe GitHub repository or any other repository, so you are supposed to invoke a trigger, and that trigger is nothing but the webhook which will perform certain automation. So you might ask this question, I mean, up to this point I am good. I have a developer. Developer is going to commit his code base into the repository, maybe AWS code commit or maybe GitHub. And then what do I mean by invoke the trigger? So here I have two options. I can take the code base, build it manually, and then deploy on the required infrastructure like a Kubernetes or EKS or a EC2 VM. Okay, so otherwise, that is one option where we can use the AWS console. Second option is to go for certain automation. Whenever there is a commit, we are supposed to deploy the infrastructure on the fly. Okay, and how shall we do it? Another scenario, your project lead wants that, okay, we are supposed to perform the nightly build. Every day there will be a schedule. Whenever there is a trigger, deploy the complete infrastructure so that during next day QA team can start their testing. Okay, so let us see this scenario. So moral of the story is, we are planning to do something called as a IAC, infrastructure as a code. So you might ask, I mean, I'm a Python programmer, so what is so special about it? Or you may say that, I mean, I'm not aware about any programming language, so how I am going to deal with this one? Okay, so what we have now with us is something called as a IAC, infrastructure as a code, which provides you to deploy your infrastructure into the cloud using certain tools like Terraform. So taking a step back, again, I am planning to deploy the developer's application. So the example that I am going to cover today is to deploy the developer application into the AWS cloud. So what resources I am going to need over here? So let us take a simple example. Terraform. What this Terraform will do? Infrastructure as a code provider. This tool is developed by HashiCorp, and this is one of the best tool that you can use. So Terraform basically has something called as a Terraform configuration file. Terraform has something called as a core. This core basically interacts with the provider to build your infrastructure in the cloud. Shortly, we are going to see the example for the same. But for now, what is the moral of the story? We have a tool called as a Terraform, which I am planning to build my infrastructure using something called as a infrastructure as a code. So infrastructure as a code. Terraform is something tool that I am planning to use from HashiCorp. What is this Terraform is? Basically, Terraform consists of something called as a Terraform configuration file, Terraform core, Terraform blocks, and then provider. Let us start with the provider. Provider will tell Terraform configuration file where you are planning to deploy your infrastructure. Okay, so one of the provider is AWS, another provide could be Google Cloud, another provide we can do is that AWS or Azure. Plus Terraform will give you a facility to do write your build own template, like what we have something called as a YAML file. Okay, so we are not going to use the exact YAML file with the Terraform, but the structure will be something like that only. So this Terraform configuration, let us understand it very carefully what this is going to have. Provider we discussed just now. Terraform core Terraform package, which is actually building the infrastructure in the background, and this infrastructure will be built on Terraform configuration file. We refer them as a .tf file. TF stands for Terraform. So .tf file, popular name is main.tf. Shortly we will see that. But what I am going to see in that file? So that file will all talk about only four blocks, 4 to 5 blocks. Okay, so block, most important block is a resource block. What resource you are planning to create? Are you planning to create a VPC? Are you planning to create a subnet? Are you planning to create a load balancer? Are you planning to create a clear EKS cluster? And so on. Resource is typically a cloud resource. Cloud can be AWS cloud can be any cloud that you can refer to, maybe Azure. So here we are talking about AWS only. Okay, so one block is a resource block. What is the moral of the story? Main.tf is going to have something called as a resource block. So this resource block is responsible to create the infrastructure in the background. So simple. And this block, one more thing we are going to have, something called as a variable. What is variable? Where we are going to store some value. So if I am saying VPC ID is equal to 12345, so here VPC ID is the variable. So use of this variable is to pass the information. So if you are planning to pass the information in a single TF file, then we will go for a variable. But there is a fair enough possibility that you are planning to use the variable across the modules, across the applications. You are planning to emit the value somewhere else. So here we have one more type called as a output. We will take a deep dive what these blocks are, what is the output, what is a variable. But for current session, what we are going to think about is main.tf is our Terraform configuration file. This is going to talk to a provider AWS, and then what it is going to do is the Terraform file is going to create this infrastructure for you. So it is going to create the VPC, it is going to create the subnet, then later the security group will be created, load balancer. So in this session, what I am trying to do actually, so if you see the complete scenario, so VPC will be created, subnet, security group, load balancer, listener, target group, and then actual target. This target can be your EKS cluster, this target can be your S3 bucket, this target can be your EC2 VM or ECS, wherever you want. If it is AWS, I am totally talking about the terms that we are using in AWS, like EKS, ECS. You can do the same thing in Azure also. So we are good up to this point that yes, I have a scenario where the requirement says that okay, Amit, I mean, whenever there is a commit, you need to build my infrastructure. So in today's session, the infrastructure that we are trying to cover is the creation of the VPC, creation of the subnet, creation of the security group. These four things is what we are going to discuss in detail. I will have another session, but that is a part 2 of this session, where I am going to talk about the load balancer, how to create the load balancer, listener, and other things. So let us get it started. Step number 1, if you are planning to learn Terraform, understand the basics. Blocks is going to define something. Again, I am repeating the same story again, but that is required also. So resource block is a critical block. Resource block is directly going to talk to the AWS and build that particular infrastructure. So resource could be security group, resource could be VPC. But if I am planning to create a VPC and then the subnet and then the security group, so here you can see there is something called as a dependency. You cannot create a subnet without having a VPC. You cannot create a security group without having a VPC, or even you cannot deploy anything into the cloud without having the VPC. So, how Terraform will know what resource to create first? Okay, there are two ways to deal with this situation. Terraform will completely analyze your configuration file. It will use its own intelligence, and then Terraform is going to generate a plan for you, execution plan. That execution plan will tell you what you are going to create, how you are going to create, and when you are going to create. So Terraform has its own intelligence. Option number two, you can say something depends upon. For example, load balancer or listener is dependent on load balancer. So in order to start listener creation process, I can say that listener is depending upon load balancer. So wait for some time unless the load balancer is created. We will cover both the scenario, but theory enough, let me try to showcase you a very simple example. Here what we will try to do, we will simply set up the virtual machine for Terraform. We will configure the Terraform, and then we will do a quick deployment. So let us get it started. So let me create a virtual machine for you. What you are able to see on the screen now is my AWS console account. So what I am going to do now, I am going to install the Terraform on my EC2 VM. So I have a region called as a Paris. So let me switch back and let me go back to my original region, say Mumbai. Let me spin up a virtual machine very quickly. So I am into my EC2 account, Mumbai. Let me launch instance. What we are going to do now, we are going to use the Ubuntu. So give me some, let me give some good name. Say my Terraform server. I am trying to perform all the Terraform activities over here. I will be going with Ubuntu. So T2 or T3 series is a more than enough, which is free tier and eligible. Let me create a new key pair. Say my Terraform key. I am going to choose PPK. Rest everything I am going to keep default. Just launch the instance. While this instance is launching, I would like to take you back to this diagram now. So we have Terraform. We are trying to install the Terraform. This Terraform is going to create the infrastructure for you into the cloud. So now we are going to discuss about how to install the Terraform in an EC2 VM. So my instance is close to launch now. Running. Let me try to connect the instance. I will use putty. I need to use the key file that I just downloaded. So select the key file. Let me open it. Perfect. We are logged in into the system. So now we are trying to install something called as a Terraform. Okay, so how do we install the Terraform? So first, what is the thing that you are planning we need to do is, let me do a clear on the screen. Let me maximize it so that you can see the full screen. I am going to make an update, apt update. So what I'm trying to do now, I'm just trying to see what all packages are available so that I can proceed further. Next step is to download the Terraform dependency. Basically the dependency whatever we have for Terraform, I'm going to push it now. So now I'm trying to connect to the repository. I mean, I'm trying to install the Terraform. This Terraform is developed by a group called as a HashiCorp, a company called as a HashiCorp. So I need to install the GPG key. So let us install the GPG key and add the repository path. Now looks like I have a majority of the things that I need to install. I will do a quick update again now, so that I have a connection required with the Terraform repository. I can communicate back to download the packages and modules. Finally, install the Terraform. So Terraform is installed. So to verify the installation, let us see what version of the Terraform we have installed. Yep, I have a Terraform version 1.9.3. So Terraform is installed and configured now. So what is the next step? Okay, so if let me resize this window, let us come back to the diagram again. We have Terraform environment that is configured now. So this Terraform environment is now going to talk to AWS. But the challenge is how the Terraform is going to talk to AWS. How does it know? Number one, so that it does know by the means of a configuration file. But how about the authentication part? How the Terraform EC2 VM will be authenticated? So we have a two ways of doing it. For if you talk about Terraform, so in case of a Terraform, we have a two types of the authentication. So let me give it some different color. What I can do is I can use AWS CLI. AWS CLI, AWS command line interface, and here I can use AWS configure. That is option number one. Option number two, what I am going to do, I am going to use a rule, IAM rule. And this IAM rule will have access to build EC2 infra. What is EC2 infra? Load balancer is EC2 infra, target group is a EC2 infrastructure, virtual machine is a EC2 infrastructure, S3 bucket is something different. Okay, so if I this example will all only talk about building the VPC, building the subnet, building the security group. So this is out of scope for now, but in actual practice, what is the moral of the story? You have to add all those permissions where you are supposed to deploy the resources in AWS cloud. So presently in this example I am talking about EC2 only, so I will go with the EC2 infra rule. So so it totally depends upon how you are architecting your application, how you are architecting your cloud. Okay, safer bet is always go on IAM based. AWS configure will directly have access to the root keys, and it's not a good idea. Yes, there are some scenarios where we prefer AWS configure, but ideal scenario I would recommend is going with the IAM based authentication only. So now what is the moral of the story? I have an EC2 VM. This EC2 VM is now going to talk to the AWS for authentication. Okay. So how the VM will be authenticated? So let me go back to my virtual machine. What I need to do now, I simply need to go to my IAM, select the role, and here we need to create a role. So let me try, click create role. In the create role, the name is what service we are planning to refer. So I am going to refer EC2. So if I need a permission on EKS, then there is a different story. If I need a permission on ECS, then there is a different story. But now I need a permission on EC2. So I am going to select a EC2 use case. Next, what I am supposed to do, what permission I am supposed to do in this use case. So currently what I need is AWS EC2 full access. This will enable me to create the security group, VPC and infrastructure. If you need to connect with S3, so S3 full access. So presently I am working only with the EC2, so I will select EC2. Let me create the role. Always give some meaningful name, my TF EC2 role. Perfect. Now we have our role in place. So if I go back, I have an instance also which is pinned up. We have created this EC2 instance sometime before. Okay. So what I will do, if I scroll down and go to the security tab, here you will see that there is no IAM role. Okay. So what we are trying to do now, we are trying to implement this guy, IAM role, IAM role. Okay, and not the CLI. I will take a separate session, or you can see my GitHub repository to how to authenticate using CLI. So let us go back, click on the action tab, go to the security, modify IAM role. So looks like the role is created. Let me do a refresh and then see if I have a role. My TFEC role. What is the moral of the story? Now my virtual machine will use a role, okay, and that role name is TFEC role, and what that role is supposed to do, what that role is going to do is something like this. Let me do a refresh. This is the role, and this role will have a limited access, and that access will be limited to EC2 creative creations only, EC2 related resources creations only. Perfect. So we have an instance running, we have a virtual machine which is also created for us. Okay, so let us go back. Now we will talk something about the page 1, that is this guy, configuration. Till now we discussed about installing Terraform, authenticating Terraform. I'm planning to use AWS, so I use the AWS role based authentication, that is using IAM. So Terraform configuration file, as I said earlier, this is basically a .tf file. You can save it like a main.tf file. You can have a one or more than one configuration file. Okay, so configuration file is nothing special, but it's a plain Terraform configuration file which is having the blocks, resources, variable, output, and cloud resource that you are planning to build, example VPC. So let us talk about this TF configuration now. I will mark this guy as a red, indicating that this is in progress now. So let me open the Visual Studio for you. So a very simple example, TF file. First we will take a quick look with respect to the diagram that we have, this guy. and then we will try to understand everything. It is extremely simple. This is the example of the Terraform configuration file where we are going to have something called as a block, and block can be further customized as it can be a variable, it can be output, or it can be a resource. So go back to the code. We have something called as a provider. This provider is a AWS. Okay, so if I go back, I have a provider block. Provider block tells me about where I am planning to connect. I am planning to connect to the AWS. Okay, so provider, what region I am supposed to connect to? I am supposed to connect to the region which is stored in a variable. So you will see something called as a variable. What is a variable? Where we can pass the value. You can have a one or more than one variable in your project. So how you are going to make a sense out of it? Variable name should be purpose specific. Since I am planning to represent the AWS region, the purpose is to represent the AWS region, so I used AWS underscore region. Description, what is the purpose of this variable? This is an optional property. What is the data type of this variable? It's a string, integer, so this is the string. What is the default value? If the required value is not provided, then what to use? It's a default value. So I am going to use region U West 3, that is Paris. So what is the moral of the story? Provider is a block which is having property called as a region, and the value for this region is extracted from variable. So that's the reason you are able to see var is a keyword which is used to point the variable. So this is a variable. Beautiful part is you can create a separate file called as a variable.tf and copy this code to it. That is the structured way of writing the Terraform file, and 100% it's a recommended one only. But since we are trying to learn the Terraform, let us learn from doing the basics. Let us do some mistakes and then understand how what is a better way of doing it. So variable is a declared. Output something like emitting something, something like printing something. So to print you should have that value. So output will emit an value. That value can be printed, or that value can be shared to the external caller, another module. Okay, so second block is output block. Description, you can have a one or more than one, and then name indicates that I am planning to show or deal something with the selected region, and you can see that my region is a US3, and the value is again I am extracting from the variable. So two things we discussed over here. One, block, block of type variable, block of type output, both deals with the values. Variable will be used to share the value within the single Terraform file. If you're planning to share value across the multiple Terraform files, we need to deal with the something called as output. So next, resource. This resource guy directly represents the cloud provider that you are dealing with. I am working with AWS cloud. So what I am planning to do now, I am planning to create an AWS VPC. Okay, why I am stressing so much over here? There is a difference. This is a variable name. You can write variable name the way you want. Okay, but this with this resource, this is the type of the resource that you are planning to build in the cloud. If it is a AWS cloud, then it's a AWS VPC. If it is Azure cloud, then you will have a little bit of different syntax. Okay, so to build the VPC, there are multiple parameters required. One of the parameter that is I need to mention is the CIDR block, which is the minimum one. So for example purpose, I am creating a VPC. You can see resource. This resource tag will create the virtual private cloud VPC in my infrastructure in the region called as the EU West 3. With the CIDR block, this value, we can take this value also from the variable. From example perspective, I am trying to showcase both the scenarios. What is a tag? So tag for the resource name, what name I'm planning to use with. Then after creation of a VPC, I need to create this subnet. So dependency, Terraform is smart enough to understand where is the dependency. It will apply its intelligence. A simple theory says that if you are creating a subnet, okay, then you need to have a VPC. So here, what I am trying to do, I am trying to add or create a resource in AWS. So type is AWS subnet. I am planning to create two subnets. One is a public subnet. This is public subnet. Another is resource same type AWS subnet. This is a private subnet with VPC ID. So how to get the ID of the VPC? Okay, so AWS VPC is the type that I am referring to, and I am planning to exchange the data available in this resource under the name main. You can change this also, but I will prefer name main. So AWS VPC dot main is referring to the VPC which is created. It's an VPC object, and that object is having a method called as ID, which will give you the VPC ID, which is unique, and then you will have something called as a name also. So subnet will belong to what CIDR block. Then this subnet needs to have a public IP on launch, so that if I am attaching a Kubernetes cluster or an task or an EC2 VM, that task should be publicly accessible. So subnet will have a public IP. So map public IP on launch. What availability zone it is? If you create a VPC, if you create a subnet into AWS console, you have to answer all these questions. So these are the minimum one that I am trying to provide with the help of Terraform. Okay, so resource tag, public subnet created. Same is the case with the private subnet. Private subnet is also created. So public subnet, private subnet, one. So, what is the moral of the story? Terraform will use its own intelligence to determine that if he is planning to create this subnet, then he is supposed to create the Terraform is supposed to create the VPC first. And how the information we are exchanging over here is with respect to the variable, with respect to the output. Okay, so now since we are talking about something called as a output, okay, we have something called as a module. This module will be responsible to create this security group also. Okay, but I will limit the today's session to create the security group, to create the public subnet. So and remain rest of the part I am going to cover in another session. So you might wonder, Amit, how I am going to recollect all this. Okay, so you are not supposed to remember this everything. You can always go back to the to the Terraform developers website, HashiCorp website, where you will be able to see all the schemas available. Once this session is done, I will share you the URL where you can see the structure and how to code that structure. So let me connect to my virtual machine now. I am already connected. So let me start a WinSCP session so that I can deploy this file to the Terraform. So my Elastic server IP, this guy, let me copy the IP, connect to the WinSCP. This is the key that I created. Perfect, I'm logged in now. So this is the example that I am referring to. This example is available in my GitHub repository. You will be able to see the link of this GitHub repository. So modules again, we will cover this for a next session. Let me upload. the file. So if I open the main.tf, main.tf is simply the same file that we have, which is talking about some provider, some region. And then if I come back to my VM again, these are the files, those are available. So now, most important, I have a virtual machine which is configured with the role. Configuration file, we talked about something called as a provider. We talked about blocks, where we talked about variable. Output we talked about in today's session. Then resource we talked about in today's session, and then blocks also. So next thing, my configuration is ready. So what I am supposed to do now, I am supposed to run the configuration. So how, what is that it tells Terraform to deal with this configuration, use this configuration? So Terraform init, Terraform initialize will download the plugins from the repository that we have configured during installation. Okay, so what I am trying to do over here, I am trying to connect to the AWS provider. So here you can see that a HashiCorp plugin is in getting installed over here, signed by the Terracorp, and you can see the version. Why? Because I have mentioned my provider is going to be AWS here. Next, provider is installed. Let me go back to my putty console. Terraform. So I am a developer, I am trying to learn, I want to learn something about what is going in the background. So what I will do now, I will maximize this window, and the command that I am going to execute is Terraform plan. So Terraform plan will show you execution plan. What all are the steps that will be performed in the by the backend? Okay, and what all are the, what is the structure? So if you see, private subnet will be created. So Terraform will be used the selected provider, that is AWS provider, to generate the execution plan. So your subnet, private subnet, public subnet, subnet name, map public IP on launch false, map public IP on launch true. You can see the other values also. So if you want to use those values like what we use the map public IP, you can use from here, or you can refer from the HashiCorp official website. VPC will be created. CIDR block. So description managed by Terraform. ARN. Since the resource is not created, that will be indicated as a known after apply. So this is a execution plan. This tells me what all resources will be created in the background, what will be deleted, what will be updated, what will be created. Okay, so now apply. Apply is going to run the Terraform with the help of configuration file. It will connect to the Terraform API, and then it will use its libraries to deploy the infrastructure onto the cloud. So apply will ask me for a confirmation, or apply will apply the changes directly. Auto approve. What is auto approve? I can call this command from my AWS build project. Okay, I can execute this Terraform file from my AWS code build project, or from any other build provider in a CI/CD environment. Okay, so there who is going to say yes? So there is a flag called as auto approve, which will automatically do the deployment without any confirmation. But for now I will skip this guy. Terraform apply will again show you the execution plan. What is going to happen? Plan to add 4 resources, to 0 to delete. What those 4 resources are? Let us take a quick look. Subnet 1, subnet 2, VPC 3, and security group 4. So, yes, VPC creating, subnet creating, subnet security group created. You can see that it is automatically trying to identify the dependency. First VPC was created, then public subnet, private subnet. Perfect. Resources are created now. So next step, go back to the AWS account. What region we selected? We selected EU West 3, that is Paris. So what resources we deployed just now? So resources that we deployed are VPC. So name of the VPC, main VPC with TF. So if you remember, we configured this guy as a tag, resource VPC, and then name Terraform. So this is created. This VPC is associated with two subnet, one public subnet, private subnet. Same we can refer over here, public subnet, private subnet, private subnet. And then if you go to the subnets, you will be able to see two subnets over here, public subnet, private subnet. So if I select this public subnet, hit edit, and then edit subnet setting, you will see that this is enabled. Why this is enabled? Because map public IP on launch, that is what we have selected as a true value. Let me cancel it. Private subnet, you are not going to see it like this. And if I go to security groups, here is the security group that we have now. Okay, so this entire infrastructure was built using Terraform as per the diagram that we created. Here it is. In the part 2 of the session, what I am going to cover is we will proceed with the load balancer, we will proceed with the listener, we will create a target group, and then we will do an ECS based deployment. So this session I am going to split into the two sessions, part 1 and then part 2. So quick summary, what we need to do. I will share all the links and everything into the group. So let me go back to my Terraform VM. So like we have apply, we have something called as a destroy also. So for now, I will not destroy the infrastructure. Okay. So what I will do, I will go back to my VNSCP. I will do a refresh. Here you will see that there is a file which is generated. That file name is having a name called as a TF state. So this is the state file, one of the most important feature provided by Terraform. This state file will have complete information about the deployment that was performed. So what do I mean by that? Let me download this state file or I can open directly. The state file looks something like this. The resources that you have deployed with their complete information. For example, if we deployed VPC, so you can see that the VPC ID. So what was the deployment? The deployment blueprint is what we can say the state file will have. So when I am trying to run this command called as a Terraform destroy, how do it know that what to destroy? So Terraform destroy command is going to refer the state file. State file, you can store the state file on your local EC2 VM, or you can store the state file in AWS S3 bucket also. So if you are planning to work in a team where multiple members will be included into the deployment, where the state file will be shared, So what we are going to do, we are going to refer the state file from some bucket, but that is out of scope for now. So let me perform the destroy. Here I will use auto approve. This auto approve will simply delete the complete infrastructure with the help of state file. So destroy complete, resources for destroyed. So if I go back to my AWS console, here let me do a refresh. This guy should disappear. So security group not found. So one member is gone. Then if I am going back to the VPC, there is only one VPC. The other VPC created was deleted, is deleted, and now there are only two subnets now, three subnets now. The public subnet and the private subnet is completely deleted. So if we come back to the diagram again, so Terraform uses configuration file which includes the provider, blocks, output block, resource block, and with the help of these blocks we are going to deploy the infrastructure with the help of Terraform core API. So that is what we technically refer as a infrastructure as a code. I will share the recording information, record article on this information along with the post. You can see the details over here. Further, if you would like to learn more about the Terraform, if you would like to learn more about the AWS DevOps, please feel free to visit our website www.techjobsolution.com. We have our training institute located in Madhapur. We conduct both courses. We conduct online courses also, where the instructor is a real time like me, and then we have a center also where you can come and join us. Details about this article, details about the examples I will attach with the post. Thank you. Thanks everyone. Thank you.